Assalamualaikum and good evening. So today we are from group 7. We want to present experiment 1, which is the stability of floating body. So my name is HAREEZ Ibrahim Harisham. I want to present my part, which is abstract, objective and introduction. So for abstract, the potential energy of a system in stable equilibrium has a minimum value. This property is used to derive a formula that is useful in determination of stability of a floating body. It is found that a floating body is in stable equilibrium if its center of gravity has a minimum height with respect to its related center of buoyancy. So the metacentric height is a measurement of the initial static stability of a floating body. It is calculated as the distance between the center of gravity of a ship and its metacenter. A larger metacentric height implies greater initial stability against overturning. So there are several results that we obtain in this experiment, which is the metacentric height for in test 1 is 0.0806 meter. The metacentric height in test 2 is 0.1091 meter, and metacentric height in test 3 is 0.1336 meter. So it's shown that the stability of floating body is affected by position of metacenter. So for objective, this report is prepared for the sake of discussing about the principle of fluid mechanics, which is the stability of a floating body. It is related with the concept of center of gravity and the equation of buoyancy. Thus, the objective of the experiment is to determine the height of metacenter using the tilting method. The x and theta values are obtained by putting the pontoon and pillar with horizontal and vertical weights into the water tank. So next one, introduction. So in this experiment, it is important to have the knowledge on the stability of pontoon, such as a floating ship. Whether the equilibrium is stable, neutral or unstable is determined by the height of its center of gravity. In this experiment, the stability of pontoon may be determined with its center of gravity at various heights.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafami Muhammad Nazri. So I will present for my part, which is theory and methodology. So for theory, as you can see in our slide, it shows that figure 2 and figure 3, which explain the stability of the floating body. For figure 2, which is stability of floating body for stable configuration, it explains that if the center of buoyancy C is greater than center of gravity CG, it's cause the floating body can be stable even though the center of gravity lies above the center of buoyancy. For figure 3, which is stability of floating body for unstable configuration, it's explained that if the center of buoyancy is less than center of gravity, it can cause the buoyancy force and the weight to form an overturning couple, which can lead to unstable configuration of floating body. So this the symbol, some of symbol that we use in our experiment. The first one is W, total mass of pontoon with the vertical weight kg. W, mass of horizontal weight in kg. GM, which is height of metacenter in millimeter. BM, length between center of body and metacenter, and others. So this is a given data that we used in our experiment. The first one is mass of horizontal weight, which is 0.28078 kg. Total mass of pontoon with vertical weight 1.16567 kg. Width of pontoon B 0.2 meter, and last one is length of pontoon L 0.35. The given data we will use in our calculation later. In this slide, is explained that the pontoon will tilt if there is a horizontal weight is moved a distance x from the center, which the pontoon will produce an angle of tilt that can be determined by using the plumb bob. So overturning couple, which is C naught, this slide is explained about calculation. So overturning couple, which is C naught equal to WGX. Right turning couple CR is equal to WG times GM times theta. For equilibrium, which is C naught overturning couple is equal to CR right turning couple. then GM is equal to Ws divided by W tan theta. For calculation using area of second moment, Bm is equal to I second moment divided by volume, where I is equal to L times B cube divided by 12, while V volume is equal to W divided by density. Therefore, Gm is equal to Bm minus Bg equal to Bm minus Y plus D over 2. For methodology, for apparatus, this is the sum of apparatus that we use in our experiment. The first one is water tank, second vertical wake, third thread, fourth horizontal wake, fifth funtun, and last one is funtun stabilizer. So for methodology, we have two parts, which is part 1 and part 2. So the first step is horizontal wake is being removed and the height of vertical wake is attached to the mass of the funtun. The center of gravity, the center of gravity CD is determined by setting of funtun mass on the funtun stabilizer. The center of gravity length, which is half the distance from the funtun base, is measured to the center vertical wake. The horizontal wake is being fixed, and we have to make sure the thread is located at 0 mark, which is no tilt. Fourth, the tank is filled with water and the funtun being placed in the tank. Fifth, measure the length of the funtun that immersed in the water. Sixth, the horizontal wake, which is 10 millimeter, is shift to the right and tilt. The angle of tilt of thread will be recorded. 7. Repeat the step 6 by shifting the horizontal wake to the right for an increment of 10 millimeter and record the angle of tilt. The step is being repeated until the plumb bob, which is hanging on the thread, reaches the side of funtun. Step number 8, repeat the step 6 and 7 by moving the horizontal wake to the left. The last step is the height of vertical wake is adjusted to the new height, and step 1 until 3 is repeated and followed by step 5 until 8. The test was done for 2 different values of vertical wake. So that's all for me. Thank you.
Assalamualaikum. My name is Muhammad SYAFIQ, and I will be presenting the part of result, discussion and conclusion. This is the result for test 1, and this is the result for test 2. This is the result for test 3. The calculation: GM equal to WS per W tan theta. Sample for test 1. So we get 0.0344 meter. BM equal to I per V, and by substitute a value for I we get 2.3 exponent negative 4 m power 4. To find V, we get 1.16 exponent negative 3 m power cube, and BM we get 0.2 meter. GM for test 1 we get 0.0806 meter. For test 2, 0.1091 meter, and for test 3, 0.1336 meter. Discussion: the value of GM from the plotted graph when theta equal to 0. This is the graph for movement to the left and to the right for test 1. And this is for the test 2. This is for the test 3. To conclude, for test 1, movement to the right 0.0298 and to the left 0.01667. Test 2, 0.0650 to the right, 0.0544 meter to the left, and for test 3, 0.0911 meter to the right and 0.0722 meter to the left. We can see that the values of GM were not consistent with each other. Value for test 3 wishes to height. This could be happen due to some errors when conducting the experiment. 2. Value of GM using an area of second moment versus value of GM from the plotted graph. You can see here, this is the graph for test 1, test 2 and test 3. So to simplify it, we put in the table and we get to see the differences between GM from equation and from the graph. So the GM value that we obtain from the graph are significantly different with the GM values calculated from the equation. The equation was dependent on distance between the base of Panton to the center of gravity, the length of the Panton that submerged in the water, and the volume of water displaced. You can see the differences of the GM. 3. Reliance of metacenter on the position of center of gravity in terms of stability on floating body. The metacenter depends on the position of the center of gravity of body. The CG increases as the GM increasing. Metacenter is the point where the vertical through the new center of buoyancy meets the original vertical through the center of gravity after a very small angle of rotation. From the diagram, you can see that when the body is in equilibrium position, force of buoyancy Fv is equal to the weight of the body. W will be downward, passing through the buoyancy center B and gravity center of body G. When the Panton is tilted at certain angle theta, the action line W will not passing through B anymore, but rather to passing through new buoyancy center. 4. Effects of variation in angle of tilt on the position of metacenter. From the equation of GM equal to Ws per W tan theta, we get GM is inversely proportional to 1 over tan theta. The position of metacenter is affected by the change of the angle of tilt. The metacenter was inversely proportional to tan theta. When the value of angle theta increases, the value of GM will decreasing, and vice versa. Conclusion: we were able to determine the height of metacenter by using the tilting method. The value of GM obtained from the graph was significantly different with the values of GM obtained from the equation. This could be happen due to some errors that happened during conducting the experiment. So to prevent this, we need to take some precaution steps such as parallax error should be avoided when taking the reading, and ensure the plumb bob really stop before taking the reading. Thank you.